Hello, welcome back. In this segment, I will discuss the meaning of mull instruction. Mull means multiplication. Suppose you have, say, your EDX register with the value 0, ECX with the value 2, and EAX is 2 power 31. If you write this in binary, it will be 2 power 31 because I have 8. 8 means 1, 0, 0, 0, followed by 28 zeros. So overall, 31 zeros, and this is 2 power 31. Okay, so we have 2 power 31, and the goal is to now multiply using the mull instruction. Okay, so what are we going to multiply? This is EAX, right? EAX is 2 power 31, and we are going to multiply this by 2. So ECX is 2. What is the product if you multiply 2 by 2 power 31? You will get 2 power 32. 2 power 32 would require 33 bits. Okay, we can't represent in 32-bit representation. We need 33 bits. However, the mull instruction is pretty smart. What it does is it stores the least significant 32 bits into the EAX register and the most significant 32 bits into the EDX register. The meaning of this mull instruction is take this value and multiply it with EAX, right? It's computing ECX. In this case, ECX is the register, and multiply it with EAX. Okay, when you multiply two numbers, say both of them are 32-bit numbers, you will get a 64-bit number, and you don't have room for a 64-bit number in one register. So what mull does is it's going to store the result into two places. One is the EDX register, which will contain the most significant 32 bits, and then the EAX register, which will contain the least significant 32 bits. Okay, so let's instantiate this for this particular example. In that case, EDX itself is 0 at this point. And when we multiply ECX by EDX, we get, what did we get? 2 power 32 for this example. 2 power 32 means you will have, let's assume for a moment we are dealing with 64-bit numbers. That means you will have 32 zeros. And then in the 33rd position, you'll have 1, which means this is 2 power 32. And then you'll have all zeros in the beginning. Okay, the least significant 32 bits. So the least significant 32 bits will go into the EAX register. So the EAX register will be 0 at this point. After the mull is done, EAX register must be 0. And what about the EDX register? The EDX register will have the most significant 32 bits, which are from here to here, which means it's just 1, right? 0, 0, 0 all the way to 1 means 1. So EDX will have 1. Okay, that's all, which makes sense because when you multiply 2 power 31 by 2, you get 2 power 32. And 2 power 32 is represented using two registers. Okay, in this register we put 1, and in this register we put a 0. That means you have all zeros. All 32 bits are zeros, and here of course all zeros in the beginning. So you have 2 power 32. Okay, so that's basically it. Let's confirm all of this using quick demo. I'm going to put a breakpoint just before multiplication starts, so you can see the state of EDX. Okay, what is the state of EDX? Must be 0. I will run it. Print x EDX is 0, and EAX is 2 power 31. And now we will do multiplication. Okay, what about ECX, by the way? ECX is just 2. Now we will do multiplication and then print all these registers. EDX is 1, as I explained on the whiteboard. EAX will be 0 because the least significant bits will be 0. All the 32 least significant bits will be 0 for 2 power 32. And 2 power 32 means only one bit has to be turned on, and that bit value will be 1 if you treat that as a 32-bit number. Okay, that's basically it. So mull means unsigned multiplication. If you do the same for signed types, you will replace this mull by imull. Okay, that's the only difference. So to sum up, what we learned is that mull instruction, let's say this register name is yes for a moment to make it general. If you say mull yes, what it means is that it's saying yes times EAX is what it is going to compute, and it's going to put the results in two places. One is in the EDX register, the first 32 bits, the most significant 32 bits, and then EAX register for the least 32 bits. Okay, that means if you have two numbers, both of them are 32 bits, if you multiply, you get 64-bit number. And the first 32 bit will be, meaning the most significant 32 bits will be in the EDX, and the least significant 32 bit will be in EAX. That's exactly what I have demonstrated to you. Okay, that's all. Thank you very much.